Hi, students have been asking about the word problems from chapter 7. And again, I'm just going to go through the 5-step process, but the first step in the 5-step process is to draw a picture. So it says, find the dimensions of a rectangle of the greatest area whose perimeter is 20. So my first step is, well, I'm going to just draw a rectangle. I don't know any of the dimensions. Many people have called them sort of length and width with W and L. So second step is to just remind people whatever variable you pick, make sure that you're defining that. And all it tells at this point is that the perimeter, so I'm going to call that P, the perimeter is, well, 2 lengths plus 2 widths. Now it says find the dimensions of the rectangle of the greatest area. We do know that area equals length times width. Let me erase that. Length times width. So these are our two equations. In the first equation, we actually know what the perimeter is because it's given to us. So this equals 20. We don't know the area. That's what we're trying, that's part of the problem. So what we're going to have to do is we're going to have to use some substitution. Because they gave us the 20, we could solve this first equation for length or width. It's really up to you. So again, maybe let's solve for width. So the first thing I would do if I was solving for width would be to subtract 2L from both sides. So it would be 20 minus 2L. Then I would divide by 2. So width would be 10 minus L. Once you have one expression for your variable, again, we don't know what the maximum area is, but we know that area is length times width. And now we have an equation for width in which we can substitute in for. So it's just using your given information, finding one of the variables and substituting in. Now, before we distribute, recognize that this formula is in factored form. Okay, why is that important to recognize what form it's in? Well, in factored form, that tells you that if the area was 0, what would the length be? Well, the length would be 0, or the length would be, 0, or the length would be 10. So what? Why does that help us? Well, again, if you're thinking about your graph, here's my XY chart. 0, 0 would represent, again, X represents my length, and Y represents my area. If my length is 0, my area is 0. If my length is 10, my area is 0. So I find this just in itself to be really helpful because now I have two x-intercepts. I also trying to find the greatest area. I have to recognize that that means that the area is going to go up and the area is going to go down. And what that tells us is because parabolas are symmetrical, and if I could draw it symmetrically, the axis of symmetry should be right in the middle. The axis of symmetry should be at 5. So by recognizing this is in factored form, I now actually know x, and in this case the length is actually 5. And that's actually part of the question, find a dimension. If your length is 5, well then what's your width have to be? Well, that means your width has to also be 5, and that means that your greatest area has to be 25, and in this case, centimeters squared. So find the dimensions. Length would have to be 5 centimeters. Width then becomes 5 centimeters, and the area becomes 25 centimeters squared. But by recognizing this is in factored form, that allows you to find your x-intercepts, and then you know your axis of symmetry is right in the middle. So that's kind of how I set up question number 11. I have my picture, define my variables, write my equations, solve one of my equations, substitute it into my equation, and then use my concepts of this chapter. Okay, let's look at question 12. So question 12, there's no picture when it says find two numbers such that their sum is 20 and their sum of their squares is as small as possible. So the first thing I'm going to do is find two numbers. So let's make x is a number and y is a number. I'm defining my variables. Find two numbers such their sum is 20. So that means x plus y equals 20. So write my equation. The sum of their squares, x squared plus y squared equals something, sum of squares. Again, very similar to our area problem, we don't actually know this number. We only know that the sum of the two values is 20. And again, just like we did in the last one, that means I can solve for a variable. Let's solve for y. That means y would be 20 minus x. Once you have a value for, or an expression for one of your variables, then you go down here and say, well, that means it's x squared plus 20 minus x squared equals sum of squares. Still don't know what that is. Okay, I still want to find out what that smallest piece is, but I can't recognize, like, this is not in standard form at the moment. This isn't in factored form. Oops. This isn't the square part. This is a square part. So I actually have to take care of that squared. So this would be x squared plus 20 minus x times 20 minus x equals sum of squares. X squared plus distribute 20 times 20 is what? 400. Minus 40x minus x squared equals sum of squares. Let's see. As I kind of going through here, I'm like, okay, oh, this should be a plus sign, double check. 400, negative 20, that's a positive x squared. So I actually turn out to have something in standard form, a positive 2x squared minus a 40x plus 400 equals smallest of the sum of the squares. Now, this is in standard form. Go back to your graphing chapter. You could find the vertex by completing the square. I'm actually going to take this and, just like I did in the last one, what if the sum was 0? Well, that's going to help me find my x-intercepts. So let's see, maybe I would factor out a 2. Again, I can use any method I want. I chose to factor out a 2 here. Is there anything that multiplies to 200 that adds to negative 20? The answer is no, there's no factors that can work. So if I'm going to solve this, I'm probably going to have to use the quadratic formula. Again, why is this helpful? If I can find my x-intercepts or find my zeros, I can do that. So x equals opposite of b plus or minus b squared minus 4ac all divided by 2a. And then finish. Oh, so we solve it and we find out, oh no, my x-intercepts are imaginary. But that's okay, because if you remember when you write something in the quadratic formula, this is always your axis of symmetry, plus or minus some value. So what does that tell us? Again, remembering that this is a parabola, because it's an x squared, just going to kind of sketch it out. This is an x squared. It's concave up, so it's going to have a minimum. And what's happening is at 10, axis of symmetry, it's actually opening up. If that's my axis of symmetry, that's also my minimum value. And again, we said that's x. So I already now know, oh, what if I find the two numbers? X is a number, x is 10. 20 minus 10 is also 10. So finding the two numbers actually is related to the axis of symmetry. And again, when you do your quadratic formula, whatever you're adding and subtracting to is your axis of symmetry. That's where your minimum in this case will be. Okay, let's take the last part of this video to look at question 13. So again, first part of this is draw a picture. I don't really have a picture to draw for a financial equation, but I have an equation. And it asks what is the maximum amount of money she will have in her account in 2009, and when does she break even? So again, if this is your x-axis, really what's happening is her account is going up in money, it's coming down in money, maybe she was in debt and whatever. We want to know this point, that's your maximum. We want to know when does she break even. We want to know our x-intercepts. So I actually think that finding the break-even part is the easiest because it's when is this equation equal to 0? Oh, well, if it breaks even when it's equal to 0, you can use any of your solving methods. If you like quadratic formula, then use the quadratic formula. And just find out those 2 points. So if you use your quadratic formula, simplify it, you get 4 plus or minus 5 square root of 2 over 2. That's not very pretty, but it asks when does she break even? Well, just add those into your calculator. 4 plus 5 square roots of 2 divided by 2. It turns out if I add them, I get 7.5. And if I subtract them, let me check my calculator real quick. I get 0.5. Again, these are approximations if I round. So when will it break 0? These are my x values right here. So here, this must be, here's my axis. This is about 0.5, and this is about 7.5. So where would the axis of symmetry be? The axis of symmetry would be at x equals 4. So it asks, what is her maximum amount? Well, that happened in the 4th month. So you're just going to take your equation and plug in 4 into your equation and find out what you get. And when you plug that in, you get 25. So the questions were, what is the maximum amount of money Jane has in her account in 2008? $25 is the max amount. And when does she break even? Well, the 7th month is like July, middle of July, July, and this would be somewhere in January. So again, those are the 3 word problems. If you have other questions, don't hesitate to email or ask. Thanks.